chemistry learners and all those who love to learn chemistry. As the beginners of chemistry studies, we are going to see electronic configuration today. So what I can tell about electronic configuration is that it is a way we arrange the electrons in their shells and subshells. So we know that atom has three main particles: electrons, which are negatively charged, protons, which are positively charged, and the neutrons, which are which have no charge. They are zero charges. So neutron and protons, they are in the nucleus. In chemical reactions, only sharing electrons involved in all chemical reaction. When there is an involvement of nucleus, we call it nuclear reaction, which means they can share, it's not to share, but an atom can split its nucleus to form new elements. So it means when an element loses electron, it remains the same. It remains the same element. But when an element loses a proton, it means it changes even the name. It changes into another type of element. So I know that what we are learning today as the beginners, it's all about the chemicals, chemical reactions, not nucleus or nuclear reaction. Nuclear reaction, we shall see it when we continue to learn until we reach on the advanced chemistry. But as the learners, we can see how electrons get shared or how are shared among different atoms or different elements, which is called chemical reactions. Here I can show you by using a diagram. We saw that this is a nucleus. Here, for in electronic configuration, we are not going to call this nucleus. We are going to call it the first shell. It is not nucleus, because electronic configuration is all about the arrangement of electrons. What I can say about the electron arrangement, electrons, they are not stable in the shells. They are always in movement. They have two accelerators of the movements. It is the attraction from the nucleus of the atom, an atom, and also the repulsion among or between two electrons, because electron and another electron, they are negatively charged. When they are going to collide, they repel like this, which means they involve in increasing the speed. When they are going to hit each other, the one it divert like this. And also there is another attraction force which is coming from the protons of the nucleus. So those are two forces which make electrons not staying at rest. They are always in movement. They are not stationary. They are not at a station. They are always in a movement. So if we say this is the first shell, they are the rules of filling these shells. Let me see that this is the first shell, this is the second shell. When we are studying the atom, we were also making the same diagram where this one was standing for nucleus. Today it is not nucleus, but it is the shell, the first shell, which means this is if it has two shells, if an atom has two shells, this will be the outermost shell. This we can call this innermost shell, and this it is called the outermost shell. Shells, they are the energy levels. Energy levels, I told you that, for example, let me try to borrow the nucleus here, like and neutrons. Here they are positives, and here they are electrons. Positives and neutrons. We can ignore neutrons because they have no charge. And here there is attractive force. If electron is here, it can move to be attracted here. and this one, the same time, it come to be attracted here. If electron meets with another electron here, they repel. If they repel, one can, which was coming from here, can also be, can jump to some level here when it is running to meet with, to repel with this one, and this one can also continue to this. So this movement of making like this zigzag, like this, attraction, repulsion, like this, so it make these electrons to have the energy levels. It depends. If electron can jump from here to here, it is not all electrons make this movement from here to here. Some they can jump up to here, another can jump up to here, another can jump up to here, up to here. So scientists, when they are determining the energy levels or shells here, it's like to take a picture of the different pictures of an atom with these particles here. And when they are taking pictures, they are seeing that they are shells. They see, if they take first picture, they see here maybe they are 2 electrons, and here they have seen like 80 electrons, and here also 80 electrons. It can also depend on the number of electrons in an atom. If there are many, you can find more here. If there are many, also the shells, the number of shells, they increase, because the first law in electronic configuration, it says that for the innermost shell, or the first shell from the inside, it holds only 2 electrons, and the second, it holds 8 if they are there. So, and the third, fourth, fifth, and so on, also they can hold only 80 electrons, which means the maximum from second shell and above shells, to from second shell to the outermost shell, each shell can hold the maximum of 80 electrons. It is also called the octet rule. Octet rule means when a shell contains 80 electrons, it fulfills the law of octet rule. So that octet rule, it can be it is used when an atom is sharing electron to make a reaction. They have to balance, so they make sure that the outermost shells, they remain octet, or they remain full. So I can clean here. Let me see. Let us see how we do configuration. Configuration it depends on the number of electrons. For example, if we say electronic configuration of hydrogen, you know that hydrogen, it has atomic number 1, and also the mass number also it has 1. Here it is stands by Z, or atomic number, and here it is also a atomic mass. So here I can say electronic configuration. If it is 1 electron, you first build one shell, the first shell, and fill it using the atomic number, which means hydrogen atom has 1 electron. It will be here, and make like this, like cross like this, which means the electronic configuration of this, it is this. Here you can indicate it like by writing 1 like this. Let us see helium. Helium is like this. Helium, it has 2, Z equal to 2, and also A, it is equal to 4, for example. So here we can say that it has 2 electrons, because the electrons, they are equal to the proton number, or the atomic number, when an element is stable, which means when it is in its nature, when it did not react with anything. It has the atomic number always equal to the number of electrons. Here it will be 1, and when you are going to write here the second one, for the first shell, they are always closed together. They are always closed together to make a pair. This one, it is always called the lone pair, but because this is a noble gas, even lone pair we will not use it, because when you continue to study, we will see that we will see what you call valence electrons. We saw them the other time. Valence electrons, they are those electrons in outermost shell when they are single. When they are single. So when they are single, they are called the valence electrons. And here, when they are double, we call them lone pairs. Lone pairs, they make a reaction because they can make covalent bond. We shall see the types of bonds during the reaction. Because this one, the valence electrons, they make ionic bonds. We shall see it in next lessons. So this one, we don't call it lone pair because we cannot call it lone pair. It is a lone pair, but we don't call lone pair as noble gases. Helium, it is a noble gas, and the noble gases, they don't react. So we make sure that we make two. So let us see the third one. It is, for example, it is lithium. Lithium, Z of lithium, it is 3. Where A, it is 7, for example. We can call it 7. We round to 7. It is 6 point something, but we round to 7. So here we write it like this: first shell and the second shell, because it has 3. The first one must contain only 2. We write that it contains only 2, the maximum of 2. The innermost shell, it contains the 2 electrons only. Then when we have remained with 1 to make 3 of lithium, so 1 will be here. I will text here, for example. This is electronic configuration of lithium. Let us see here. We note this like this. But here we will note this like 2 for the innermost shell, and then the colonels, and then 1. 2 and 1, which means when you are going to note down the electronic configuration, you note a shell by shell and separate by these semicolons. So, for example, let us see like lithium. Lithium we have done. Let us see sodium, for example. Sodium, we can put sodium here. Sodium, it is 11, and also it has 23. This is the mass, but we always look at Z when we are in electronic configuration. This is A. So here we'll say that sodium, it has 2 electrons. We will reach the first shell is full now because it must have a maximum of 2. Another one, it must have a maximum of 8. These are 2, then 3. Look at here. I am filling. When you are going to fill the second, from the second, you first fill the 4 corners. 1, 2, 3, 4, and we want 11. If we want 11, we will make it like this. This is it. 1, 2, 3, 4, 5, 6. Then we start to make pairs. 6, 7, 8, 9, and 10. The total, here they are 8, here they are 2. The total is 10. So if the total is 10, here we are remaining with 1, which means we will create another shell. We have to create another shell because we have remained with 1 electron. We will put it here. So the electronic configuration of sodium, it is done now. It is done. So here, the first shell, it contains 2. We note it like this. Another one, it contains 8. And the last one, it contains 1. This is how we do the electronic configuration. So I don't know if you have any question here that you can ask, because if you are having any problem, you can ask down here. But these are the simplest way to make electronic configuration. There are other electronic configuration methods and other advanced theories about the electronic configuration, especially inside these ones. They are subshells or sub-energy levels. It is in advanced chemistry, but remember that here we are studying the fundamentals of chemistry. We don't go very deep. This is very enough for the beginners.